In this example, we will solve a problem related to freely falling bodies. A €1 coin is dropped from a leaning tower of Pisa. It starts from rest and falls freely. Compute its position and velocity after 1 second, 2 seconds, and 3 seconds. Based on the problem we are given the following information. Starts from rest, so initial velocity is 0 or v0 equals 0. Falls freely, so acceleration is g equals 9.8 meter per second square. Based on the figure it falls at a certain height set as origin, so we set the time t0 equal to 0 and initial position y0 equal to 0. Times are given, 1 second, 2 seconds, and 3 seconds. So we have the following parameters. v0 equals 0, t0 equals 0, y0 equals 0, g equals 9.8 meter per second square, t equals 1, 2, and 3 seconds. Let's recall the table of equation of motions for motion along the vertical. We then compare it to the given values we have extracted directly and indirectly from the problem. Recall that we are asked to find the position and velocity at times t equals to 1, 2, and 3 seconds. For the position problem we see that the equation fits with what we want since it contains variables that we know of in order to solve for the unknown. We then solve using the ideal equation we obtained in step 2. Upon substituting the values we gain that for time t equals 1 second we get that the position y equals negative 4.9 meters. Similarly, we get for 2 seconds y equals negative 19.6 meters. And for 3 seconds we get negative 44.1 meters. We go back to the table in order to solve for the next problem, which is the velocities for various times. We then add to our given values obtained from the positions and we determine the ideal equation to solve for the velocity. We see that equations 1, 2, and 4 would work. Let's try first equation 1 to solve for the velocity. We substitute the given values and see that the formula for v using equation 1 is equal to the negative of acceleration due to gravity times time. Let us substitute the different value of time, which gives us negative 9.8 meter per second. Similarly for time equals to 2 and 3 seconds. Now let us look at equation 2 to solve for the velocity equation. Rearranging the equation first, then we get that the velocity formula is equal to 2 times the y divided by time t. For time equals to 1 second we see that the velocity is equal to negative 9.8 meter per second, which is the same and should be the same as the one solved using equation 1. Similarly for the velocities using equation 2 as basis we get the same values. You do not need to use all 3 equations to solve for the velocity formula. You just have to pick one to solve it. To choose which equation depends on what type of given and choose the simplest one. For me, that would be equation 1. Using the fourth equation to solve for the velocity we get that it is a square root of 2 times acceleration due to gravity times the position y. We see that for time t equals 1 second and position y equals negative 4.9 meters the velocity is equal to the plus or minus 9.8 meter per second. We recall that a square root gives 2 values, which is a positive and a negative. So, to resolve this we have to look at the problem and see that the situation is that it is a falling object and must have a negative direction, so therefore we choose the negative value of the square root in order to make sense. So the final answer is negative 9.8 meter per second. Similarly, we do the same and obtain the same values for time t equals 2 and 3 seconds compared to values obtained using equation 1 and 2 done earlier. So the final answers are now given using the equation of motions. Remember to show your solutions systematically and box your final answers. The end for now. For questions and comments you may send them to diyslearningstuff@gmail.com. You may review the slide on YouTube at dies@dieslearningstuff. Note, please do not forget to use your school email. Also write your complete name and class section. Thank you for listening and see next meeting.